So the final thing we're going to do is talk about tangents to polar curves. So remember, we've talked about these polar equations. They look like r equals f of theta. And so we want to be able to talk about derivatives here. And so that means we need to look at our conversion equations. X equals r cosine theta and y equals r sine theta. Now remember, because we're in this scenario where we have these polar equations, really these r's here have thetas in them. This is f of theta, cosine theta, f of theta, sine theta. And so now if I want to find dy dx, I need to find dy d theta and divide by dx d theta. So we're going to look at our r equation, our y equation here, and we're going to want to take the derivative. Well, we have to use the product rule. If you look down here, because there are thetas in two different places, and so what would the product rule tell me? It would be dr d theta, take the derivative of the first, leave the second alone, and then take the derivative of the second. The derivative of sine is cosine. And now you're going to repeat that, but over here for our x equation. So you'll have dr d theta cosine theta, and then r, the derivative of cosine is a minus sine. So this is the formula for the derivative right here. So let's put this into practice. Let's look at a problem. So let's look back at our cardioid. For the cardioid, r was 1 plus sine theta. I want you to find the slope of the tangent line when theta is pi over 3. So remember, slope of tangent line, that comes from your derivative. So we need to start by finding our derivative dy dx. So I'm going to rewrite the formula right here so we have it right in front of us. This was the formula I just boxed in. Cosine theta minus r sine theta. Okay. So let's look at our r equation right here. 1 plus sine theta. You take the derivative of that, and it's just going to be cosine theta. Cosine theta. And now r, which was 1 plus sine theta, cosine theta, cosine theta, cosine theta, minus 1 plus sine theta, sine theta. And now we're going to simplify some of the stuff that we have here. So in the top, you have 2 cosine theta, sine theta. There's 2 of them, plus a cosine theta. In the bottom, you're going to have a cosine squared minus sine squared. So this is the formula for my derivative. Now what I want to do is I want to plug in, they told me theta was pi over 3 into this. 2 cosine pi over 3 sine of pi over 3 plus cosine pi over 3, and then this would be cosine of pi over 3 squared minus sine pi over 3 minus sine of pi over 3 squared. So you've got to remember your trig values on your unit circle. Cosine of pi over 3 is 1/2. Sine is square root of 3 over 2. Okay, so you can cancel these 2's and then do a whole bunch of simplifying, and when you get done, you should get -1 here, and that's the slope of the tangent line at theta equals pi over 3. So for our final part of this problem, what we're going to do is we want to find the points on the cardioid where the tangent line is horizontal or vertical. So let's start with horizontal. What does it mean for the tangent line to be horizontal? Horizontal means the slope is 0, so dy dx is 0. And so you're going to set the numerator of the derivative equal to 0. So the numerator was 2 cosine theta sine theta plus cosine theta equals 0. And these terms have a cosine in common, so I can factor that out. So either cosine of theta is 0, or 2 sine theta plus 1 is 0. So here I get the angles pi over 2, 3 pi over 2. Here I get sine theta would be -1/2. So I'm getting 7 pi over 6 and 11 pi over 6. So to get the actual points, you have to plug them back into your cardioid equation to get points. I'll list the points at the end. Now we want to know all the places where the tangent line is vertical. What does it mean for the tangent line to be vertical? Well, dy dx is undefined. So we're going to set the denominator of our derivative equal to 0. So now what I'm going to do is I'm going to switch this cosine squared. I'm going to use that's the same thing as 1 minus sine squared, just so I have the same trig function. They're all sines. And so now what do I have? I have 1 minus sine theta and a minus 2 sine squared theta. And then you can factor this into 1 and a 1, sine theta and a 2 sine theta, and a negative and a positive there. So I get two possibilities. 1 plus sine theta is 0, so sine theta would be -1. That would be 3 pi over 2. Or 1 minus 2 sine theta is 0, so sine theta would be 1/2. You get pi over 6 and 5 pi over 6. So we get the following place points where, again, you have to plug in theta back into your cardioid equation to convert this into points. So your graph has a horizontal tangent line at the points 2 pi over 2, 1/2, 7 pi over 6, and 1/2 11 pi over 6. And it has a vertical tangent line at 3/2 pi over 6, 3/2 5 pi over 6, and at 0, 3 pi over 2. So those are all the points where the graph has a horizontal tangent line and a vertical tangent line.